So I sub xc prime is equal to I sub xc plus, I don't know where we are, Peter,
Yeah.
what do you think I should put here?
Y bar squared.
Grade?
Where we at? Area mass.
Which one do you think?
By mass.
Right. Why?
It just matches
Why?
that way.
Because it's mass, because we're dealing with
Yeah.
mass. Here we were dealing with area, so we put area. Here we're dealing with mass, we put mass. Okay? So let's do an example. Remember I told you that this packet I handed out has all the numbers in it, right? So we don't have to do any number crunching. So let's go to a problem. The Elmo isn't working, but we all have the same sheet. So I'm on the next page, and it looks a little like a dam. Do you need one? What's it doing at the house? Oh, wow. Is your cat learning moment of inertia right now?
Yeah, probably.
Okay, in order to do these problems, the first thing we have to do is this problem. We first have to find out where the center is. And as engineers, when we design things, we're designing things that are a bunch of different shapes or composite bodies. So if we look at the front of this, right, we have, let's see. So go on to the next page where I worked out the problem and look at the picture. Just like we did on Thursday, we took a body and we divided it up into sections. So flip back and forth. Does it make sense that I divided it up into 2 triangles and 2 rectangles? 2 triangles, 2 rectangles, okay? And the first part of this problem is really doing, let's read the problem first. So the problem says, locate the centroid y bar of the cross section and determine the moment of inertia of that section about the ax prime axis. So, Jill, we're up to you. First off, is this a center of mass, center of gravity, centroid of area, centroid of volume problem?
Area.
Centroid of area, how come?
We're asked to find the centroid, and it's
Well,
PD.
don't, maybe sometimes like lay people will make all these words, say these words wrong. So let's just assume they don't know what they're talking about. Okay, so besides the word centroid was there, how do we know?
They give us lengths.
We're dealing with lengths and areas, right? Do they give us volume? No, they didn't give us any value of the depth. We're only looking at the front surface. So they gave us area, so we have to be doing centroids of area. Okay? And then they say they want to know the moment of inertia. Do they really want to know what this moment of inertia is? Or are they really trying to find this accepted term moment of inertia? The accepted term, why?
51
Because we're still dealing with area. Okay, they don't give us any value for mass, we're not dealing with mass at all, we're only dealing with area. Okay? Those of you who are interested in civil engineering, architectural engineering, structural engineering are going to be using this one all the time. Because we're really not designing things that are moving. Those of you who are mechanical, aero, you're going to be dealing with both all the time. Okay, so we divided the section. Do you remember what the first column looked? Take a couple of minutes to look back at the problems we did on Thursday. They're in this packet too. You remember? We did it all using tables. And we had our computers out, we could have done it all using Excel. Oh, by the way, all of you, whether you're civil, mechanical, or aero, you're going to be taking a fluids class. And when I went to college, it was the mid-80s. I mean, computers weren't a big thing really that much. But I did all my fluids homework using Excel because it was so much number crunching. I don't know if they teach it differently now and they're going to teach it all in Excel. Maybe they will. I don't know. But if they don't, do your homework on Excel because it's all tables. Don't keep punching all the numbers out, you know. Do it on Excel. Okay? It'll take you way less time. Okay, so, what was our first column always set up as? The section, the parts, right? And how many sections do we have on this problem? 4. So the first column was sections. What was the second column always representing? The critical thing, right? So whether if we were dealing with center of mass, the critical thing was mass. Center of gravity, weight. Centroid of area, area. Centroid of volume, volume. In this case, we're dealing with area. So you notice my second column is the area of each of those objects, right? So 2 of them are rectangles, 2 of them are triangles, 1/2 base times height, and then base times height. And then what was the third column? It was always y bar. It was the distances. Okay? And what I want you to do now is check my work. Go to this problem, and for section 1, which is the rectangle on the bottom, is the centroid of that 0.025? Yes. Okay, how about for the 2 triangles? The centroid should be 1/3 up, right? So it should be 0.05 plus 1/3 of 0.4. And then the rectangle in the center should be 0.05 plus 1/2 0.4. So does everybody agree with those centroids?
Doesn't matter what order we pick them in?
No, you mean what section?
Yeah.
No, you could choose whatever section you can do whatever you want. Just make sure you put it in the right row, right?
Yeah.
You want to put the area of section 1 in the section 1 row. And then what was the last column supposed to be? Remember I mentioned this at the end of last class. I ran out of room, so I don't have the last column, but what should that last column have been?
Area times y bar.
Right, so the first column was the section. The second column was the critical component, which in this case was the area. Next column was the y bar, and the last column should have been the area times the y bar. And then what do I sum up in the bottom of the column? I sum up the areas, and I sum up the area times the y bar. And then what is my y bar going to turn out to be? Isadora? So I summed up all the areas, and I summed up all the areas times the distances. So to calculate my y bar, it's going to be
Sum of the areas.
sum of the areas times the y bar divided by
Sum of the areas.
sum of the areas. Yeah, Chris?
I know if you like calculated it differently, but you wrote the square, that's the way it's supposed to be squared.
Oh, it's not squared, it's 2 times.
Oh.
It's 2 times because there were 2 triangles.
I thought it was-
Yeah, no, it's 2 times. So do it by table, don't, you know. So, was this a moment of inertia problem yet? Was this a moment of inertia problem? No, I didn't use any of those equations, bh cubed over 12, bh cubed over whatever, you know, radius, pi cubed, whatever those equations are. This was not a moment of inertia problem. This was what? A centroid problem. But, when I want to do moment of inertia, don't I need to know where the centroid is? If I don't know where the centroid is, I can't do this whole moment of inertia calculation.